welcome to part 4 of the Animal Science 105 Growth and Development Lab. In this part we are looking at how the body composition and energy content changes with body weight. So we're supplied with data of animals from sort of a 5 kilogram lamb up to something like a 40 kilo ewe, and that data, that body weight data, is then broken down into the component parts. So we have the amount of water in the body, the amount of protein, amount of fat and ash, and from that data we can see how the proportions of those components change over time, and we can also work out the energy content over time and how that changes, and from that we can actually work out the amount of energy required for the animal to gain weight at different stages in its life. And this is real data, so we'll get some real figures around those concepts. So here is the data that we are given for exercise 4, part 4. This is the same data that's in your lab manual. And what we've got here is we have a range of empty body weights down here. Now, empty body weight is the body weight of the animal after you've removed the rumen contents, stomach contents, so all of the contents of the gastrointestinal tract, which can be variable and aren't technically part of the animal. It's inside its gut. So here we have a 5 kilogram animal, and if you analyze that animal, you have 3.8 kilos of water, a kilogram of protein, and 130 grams of fat. Last column here is actually in grams, not kilograms, and this is ash. And ash is what you are left with if you incinerate the animal. And it's basically, you get rid of all the organic elements, and in the case of an animal you're basically left with mostly calcium and phosphorus, and those minerals are, majority of them are from the bones. So this is a good approximation to the amount of bone in the animal. And we have these proportions at each body weight. So a 10 kilogram animal, a 15 kilogram animal, 20 kilogram animal is 14.4 kilos of water, 3.2 kilograms of protein, 2 kilos of fat, 396 grams of ash. So what we want to do is to convert that data to the proportion of those contents in each of those weight ranges. So when you go from 15 to 20 kilograms, how much extra water, protein and fat do you get? So for the 0 to 5 kilo, it's just the same set of data here. I've just copied them down. So here, this equals 7.5 kilograms. That's the content for a 10 kilogram animal, minus what there was at 5 kilograms, and that's 3.7 kilos. And I'll just copy that across and then copy that down. So that gives us the proportion of each 5 kilogram change. So when we get up to here, 35 to 40 kilograms, that 5 kilo change is made up of 2.4 kilograms of water, 0.6 protein, 1.9 fat, 110 ash. Now the thing to notice here is water content's decreasing. The protein content of each of those 5 kilogram gains is going down, and the fat content is increasing. So as the animal gets larger, more of the body weight gain becomes fat, less of the body weight gain becomes protein. We can also work out the energy in each of these increments. In your manual you've given a couple of numbers there. you're told that fat has 39 megajoules of energy per kilogram and protein has 23.2 megajoules of energy per kilo. So in this column here, we can say that the fat at 39.5 megajoules per kilogram times the amount of it, which is there, plus the amount of protein times the energy value for protein, which is 23.2. So that is the amount of energy in that 5 kilos of body, and we can copy that down, and you can see that it's steadily climbing. That is because you have getting more and more fat as you get bigger and bigger, and fat is twice as much almost energy per kilogram as protein. Now this last table here is just further refining this table here. So here we've got kilograms per 5 kilograms gain, so it's 3.8 kilograms of water per 5 kilograms gain. What we're going to do in this table is to convert this number here into grams per kilogram. So this equals that number there, which is for 5 kilograms, so we'll divide it by 5, and to convert it to grams we'll times it by 1,000. And I don't know if you've noticed, but the formula I'm typing in here is replicated up here. Okay, so that is 760 grams per kilogram gain in the weight range 0 to 5 kilos. And I'm going to copy that across, and here I'm going to get rid of this because that number was already grams, and this one doesn't need converting to grams either because it's not that unit. So, and now I should better just highlight that and copy it down. So we can see how the water content's decreasing, the protein content is decreasing, and the fat content is going up. And the ash stays pretty much the same. The amount of bone gained in each one of those increments is pretty much the same. And here the energy value of each one of those kilograms gain is going up, and that's all represented down here. So all of these figures are graphed here. Now this final part, I'm just going to have to refresh my memory on exactly how we do this part, so I'll be back shortly. Okay, so just before we move to this part 2 here, we'll just quickly look at this. So this number down here, which is the line staying pretty flat, is your ash, so it's not really changing in your body weight gain up this end as it was down that end. I'll go to this one here. So this is the protein gradually dropping as your animal gets bigger and bigger. Here we have the fat, which is increasing. This one here is the body energy. Because most of the energy is in this fat, then the body energy is going up at the same sort of rate. And this one here is the water. The reason the water is dropping is because there is more water in the protein than there is in the fat. So if you start reducing the amount of protein and increasing the amount of fat, then the amount of water being added when you get up here is less than it was down here. Okay, so this last part here, Basically, there's a question in the lab manual, and it says, what would happen, what gain would you get if you gave an animal that was 15 to 20 kilograms 1 megajoule of energy versus the gain that you would get if you gave a 35 to 40 kilogram animal 1 megajoule of energy. So to work that out, we just go into here and we take this number here, and actually it took 10 megajoules to put on that much water. So if we divide that number by the 10, I'll lock onto that there, and I can now copy that across, and I can do the same here, equals that number there divided by 18 megajoules, and I've got what's I done there? Oh, here I can see. That's better. We just need to reduce the number of decimal places here. So what this is saying is, if I give an animal that's around 15 to 20 kilograms, if I give it 1 megajoule of energy, I will get 14 grams of protein for that 1 megajoule of energy, and I will get 17 grams of fat, 66 grams of water. If I give the same amount of energy to a larger animal, I halve the amount of protein, and this is going to be mostly muscle here. So you're halving the amount of muscle that you are getting for that 1 megajoule of energy, and you are increasing the amount of fat. So it's demonstrating that the bigger the animal gets, the more nutritionally expensive it is to increase its body weight. So you have to feed it more feed to get an increase in body weight. So that's the exercise is finished. You have got all the data in your lab manuals. You can get the spreadsheet from Learn if you want to fill it in yourself, and hopefully that's illustrated a few of the points that you will get during the lectures in a more practical form.